Domain and range review. We've gone over domain and range before. We just want to make sure that we clarify some missing information that we have probably overlooked. So for example, let's look at the first one. We're looking at a discrete function, and remember we did discrete in our first unit. And discrete just simply means disconnected. The points will not be connected. Domain, remember we associate it with x values. So every time we plot a point, for example, this one is -4, 1. -4 is our domain, and 1, which is our y, is our range. For example, y values are typically range. Okay, and so we'll go on and plot each coordinate point, and whenever we get the x value, that becomes our domain, and when we get the y value, that becomes our range. So let's look at the continuous. The continuous is when it's connected, but we simply just crop the picture. And when we crop the picture, we have to keep in mind that we can crop it from here to here, and we can crop it from here to here, but it keeps growing in both directions, and that's as far as we can crop it. So when we're looking at the x-axis, remember the x-axis is our domain, you know that we're looking at the x ruler, and our picture starts from 0 and keeps growing and growing and growing. Therefore, our domain is x is greater than 0. Okay, so now let's look at the range, which we associate with the y values, and we look at the y ruler. Well, it starts at 1, 2, 3, and it keeps growing. So we simply say y is greater than or equal to 3. Now, if you look at the last picture continues to grow in all sorts of directions. And so we're not able to crop the picture. Since we're not able to crop, we simply state that the domain is all real numbers and the range is all real numbers as well. Okay, so now let's look at the graphs where we have solid circles and open circles. When we crop our picture down below, we keep in mind that we have to pay attention to whether the endpoints are solid or open. And since these are solid, we know that the inequalities will have the line underneath them. So we know that the domain is from 1, 2, 3, -3, all the way to a +4. And we simply write it just the way we see it down below with the line underneath the inequality. Now pay attention to when we have open circles. We still continue to crop the picture, and when we crop the picture, we're still looking at the x ruler or the x number line for domain. And yes, it does start at -1, -2, -3, and it runs all the way to 1, 2, 3, 4. Except in this case, this is an open circle right here, therefore you will not put the line underneath the inequality. Whereas right here, since it's solid at 4, you will write the line underneath the inequality. Okay. So the domain includes 4, but does not include -3. Therefore, we leave the open circle. Okay. Again, on the last one, we'll crop once again, except we keep in mind that we have open circles. So if we look at our domain continues to be the same throughout. It's from -3 to 4, but this time, since we have open circles on both ends, we will not write the line underneath the inequality for either one. Now let's look at the example. After spending $15 on supplies, the French Club will wash cars for $5 each to raise money. Once we write the function is written as f of x is equal to 5x minus 15. Okay, and we're subtracting 15 because we spent money. And we need to know what the domain is. So the domain was whenever we plug in an x value, we'll input an x value and figure out what our y is. So whenever x is 0, we are negative money $15. And y can also be rewritten as f of x. Okay. When we plug in 1 for our x value, we're still negative $10. We still haven't made money after the first car wash. And we'll simply go forward and we'll plug in 2 and we'll be negative $5. And when we've washed 3 car washes, we are even. We have not made any money, nor are we in the hole with negative money. And whenever we wash 4 vehicles, we're up $5. 5 vehicles, we're up $10. And if you notice, the domain are x values and our range are y values. Okay. The second example, a plumber charges $60 for a home visit plus $40 per hour. We rewrite the word problem as a function. F of x is equal to 40x minus 60. And we would do the same. We'd plug in x values and then receive our y values from a calculation on our paper or our calculator. So if we read, hours must be 0 or more but can include fractions of an hour. And since we can include fractions of an hour, we know it's going to be continuous, so x is going to be greater than 0. Although we still can continue to fill out the table, we have to keep in mind that since fractions are included, we can just simply state x is greater than or equal to 0. Now, the lease charge is $60 and can increase from there. So we know that f of x or y is going to be greater than 60. It cannot be any less than 60 because we know we're going to charge $60 or more. And so we know that the range will be as such.